There is a peculiar and exhausting phenomenon that occurs on the internet whenever someone dares to dream a little too vividly, a specific kind of intellectual paralysis that grips a certain subset of the population when they are confronted with the concept of fiction. I recently released a video titled The Billion-Dollar Mistake, a narrative piece explicitly categorized as defense fiction, a what-if scenario visualizing a high-stakes, breathless future where Indian ingenuity capitalizes on a Pakistani and Chinese tactical error. The premise was simple, patriotic, and technically grounded in the realm of the possible. We find a dud pl15 missile, we reverse engineer its superior propellant chemistry, and we inject that volatility into our existing Astra airframes to radically extend their range. The reaction from the actual warfighters, the men who have commanded squadrons and corps, was electrifying, a shared nod to the spirit of adaptability. Yet, predictable as the tide, the comment section has been invaded by a battalion of armchair experts, the self appointed guardians of mediocrity, who have descended with their calculators and their cynicism to explain exactly why Indian scientists are incapable of brilliance and why innovation must always take a decade. It is a fascinating psychological case study, really, where the inability to read the word what if in a video description morphs into a crusade to defend the honor of DRDO scientists by arguing that they are in fact slow, bureaucratic, and bound by the laws of physics as they were understood in 1995. One of the person who I follow for a long time has asked some very good questions regarding this pure defense fiction video. Let's see we can answer, sir, convincingly. You called me a smart chap, first of all, thank you. Let us address the primary accusation first. This clutch your pearls horror that I am somehow undermining Indian scientists by suggesting they could reverse engineer a fuel grain in 6 months. The mental gymnastics required to reach this conclusion are truly Olympic grade. You are angry because I portrayed DRDO scientists as agile, genius level chemists who can deconstruct a molecular lattice and synthesize a solution while the iron is hot. You are offended because I depicted them as war winning assets who don't need triplicate paperwork to light a rocket motor. In your desperate attempt to defend them, you are actually enforcing the stereotype that our R&D establishment is a lumbering dinosaur that requires 10 years to analyze a tube of mud. That is the real insult. To suggest that the brightest minds in India, armed with state-of-the-art spectrometers and supercomputing clusters, would stare at a Chinese missile for a decade like confused cavemen looking at a monolith is the ultimate disrespect. My narrative assumes their competence, your critique assumes their stagnation. When you say it takes 10 years, you are not stating a scientific constant. You are confessing your own lack of imagination and your ignorance of how the pace of the world has shifted while you were busy polishing your pessimism. You can't just guess the grain size and ratios that fast. Let me introduce you to a piece of technology that apparently hasn't reached the rock under which you are living, the NVIDIA Blackwell architecture. We are not running simulations on a Pentium 4 anymore. We are living in an era where compute power has scaled exponentially, effectively collapsing the timeline of trial and error. Look at biology for a parallel that puts your rocket fuel anxieties to shame. For decades, the expert consensus was that decoding the 3D structure of proteins, the building blocks of life itself, infinitely more complex than a hydroxyl-terminated polybutadiene binder, was a generational challenge. It took years of crystallography to map a single protein. Then came AlphaFold. In a matter of months, AI solved the folding structures of nearly every protein known to science. It did in a year what human manual labor would have taken centuries to complete. Now, apply that logic to your complaint about rocket fuel. Propellant chemistry is difficult, yes, but it is a puny substance compared to the proteome of a human being. If we can unlock the secrets of biological life with AI in a fiscal quarter, do not sit there and tell me with a straight face that it takes 10 years to analyze the burn rate of a stabilizer in a solid rocket motor. The critique that you can't know the grain geometry from residue is another delightful piece of antique thinking. In the scenario, which again I must stress is fiction, we recovered the missile. But even if we assume we only had fragments, the days of scratching your head over a pile of ash are over. We have industrial computed tomography that can scan density variations in unburned propellant at a micron level. We have mass spectrometry that can identify the isotopic signature of the oxidizer source. But more importantly, we have generative design algorithms. You don't need to guess the grain geometry of the pl15 to make it work in an Astra. You feed the constraints into a physics engine. I have a casing of diameter x, a length of y, and a nozzle throat of z. Generate the optimal grain geometry for a dual pulse burn using this specific high energy propellant. The AI doesn't give you one guess, it runs 4 million simulations in an afternoon. It tests star grains, phenocell grains, tubular grains, and geometries that human engineers haven't even named yet. It simulates the internal ballistics, the pressure curves, and the thermal loads for every single one of them. By the time the scientist comes back from his tea break, the computer has already identified the top 3 configurations that will maximize range without rupturing the casing. The guesswork you are so worried about is dead. It was killed by warehouse scale computing, where a single rack wielded 1440 petaflops of processing power. Then there is the obsession with physical testing. The how many static tests were conducted line of questioning that reeks of a mid century manufacturing handbook. They got it right the first time? Impossible, cry the critics, unaware that in modern aerospace, if you aren't getting it right on the first or second physical try, you are failing at your job. The concept is called the digital twin. We build the missile in the digital realm first. We don't burn money and time casting 50 different motor variants and blowing them up in the desert of Rajasthan. We burn the digital twin in a virtual wind tunnel where the physics engine accounts for combustion instability, erosive burning, and nozzle ablation. We simulate the failure points. We stress test the casing virtually until it bursts, then we reinforce it, then we burst it again, thousands of times a second. By the time the first physical prototype is cast and mounted on the test stand, it is not a guess. It is the validation of a model that has already survived 10,000 virtual flights. The first time success in the real world is merely the final punctuation mark on a sentence that was written in code weeks ago. To demand years of static testing is to demand that we ignore the tools that make us competitive. Let's move on to the hardware critiques, specifically the concerns about the casing and the nozzle because they betray a fundamental misunderstanding of material science in 2026. The argument is that strengthening the Astra casing to handle the higher pressure of the Chinese CL-20 fuel would increase the weight so much that it would ruin the aerodynamic stability and range. This is true if you are building your missiles out of cast iron and hope. It is demonstrably false if you are using modern aerospace materials. We are not welding steel plates onto the side of the rocket. We are talking about carbon fiber overwrapping. We are talking about miraging steel 300, materials with strength to weight ratios that defy the intuition of a layman. You can increase the burst pressure of a vessel by 40% with a mass penalty that is negligible relative to the thrust gain. If I add 3 kilograms of structural reinforcement to a missile, but the new fuel gives me a 20% increase in specific impulse, the math is overwhelmingly in my favor. The missile doesn't care about your stability concerns because the flight control computer compensates for the shift in the center of gravity CG instantly. The control surfaces articulate a fraction of a degree differently and the missile flies true. As for the jugaad of widening the nozzle throat, precision machining is not jugaad, it is erosion management. If the mass flow rate increases, you open the throat and insert a graphite or tungsten liner to handle the heat flux. This is standard engineering. It is not magic and it certainly isn't bunkum just because you don't understand how CNC lathes work. The most laughable of all the critiques is the safety argument. When did they do the safe separation trials? You can't just put it on a jet. This brings us to the core difference between a peacetime bureaucracy and a wartime necessity, a distinction that seems to be completely lost on the critics but was immediately recognized by the military leadership who shared the video. In peacetime, yes, you spend 5 years dropping dummy missiles to ensure that there is a 0.00% chance of the missile hitting the aircraft pylon. You write reports, you have meetings, you have tea, but Operation Sindoor is not peacetime. It is a war scenario. In war, the calculus changes. If the enemy is outranging you, if your pilots are dying because they can't shoot back, you do not spend 2 years on separation trials. You run the CFD, computational fluid dynamics analysis, you verify the flow fields on the computer, you do one live fire from a safe envelope, and then you load the weapon and go to war. You accept a marginal risk to the airframe in exchange for the capability to kill the enemy. This is the history of warfare. The Israelis didn't wait 10 years to integrate new weapons in 1973. The British modified the Harriers on the sale to the Falklands. Necessity is the mother of skipping the paperwork. You think 6 months is fast? Let's talk about 1999. The Kargil war was raging and our pilots were struggling to hit tiny fortified bunkers on mountain peaks with dumb iron bombs because Surprisingly, unguided gravity bombs are terrible snipers at 18,000 feet. We needed precision and we needed it yesterday. Enter Israel. While the rest of the world was busy lecturing us on restraint or reading sanctions manuals, Tel Aviv quietly opened the armory. They shipped over lightning targeting pods and laser guidance kits. But here's the kicker, they didn't fit. The kits weren't plug and play for our specific infrastructure. Did the IAF and DRDO form a committee? Did they release a request for proposal? No. They pulled off the great Indian jugaad at Mach speed. In a frantic, caffeine-fueled sprint of just 12 days, engineers rewrote the weapon delivery software, jury-rigged the pylons, and mated Israeli brains to Indian-born 1000 Dal bombs. The result? One morning, the enemy was safe in their bunkers. The next, Mirage 2000s were threading laser-guided explosives through their front windows. We turned dumb iron into precision instruments mid-war. So don't tell me about standard development cycles. When the balloon goes up, India innovates in days, not decades. The fact that Lieutenant General D.P. Pandey and Air Marshal Anil Chopra appreciated the sentiment of the video proves this point entirely. These are men who have worn the uniform, who understand that in a crisis, speed is the only currency that matters. They saw the video and saw a vision of an India that fights to win, an India that adapts. The critics saw the video and saw a violation of a procedural handbook. And that brings me to the incredible irony of who is actually offended here. The chief of the air staff, the air marshals, the generals, the people who actually bear the burden of India's defense are sharing the video, commenting on it, and appreciating the aggressive can do spirit it represents. They are happy to rub salt in the enemy's wounds, even hypothetically, because they know the value of psychological dominance. Shiv sir, I mean no disrespect you. I love your work. Yes, your first assumption is correct about me, but second is wrong. I mean no disrespect to the DRDO scientists. Meanwhile, the internet experts who have likely never stepped foot inside a DRDO lab or a cockpit are hyperventilating on behalf of scientists who didn't ask for their protection. I have posited a world where our scientists are superheroes, not civil servants. If you find that offensive, you need to ask yourself why you are so comfortable with the idea of Indian science being slow. Why is 10 years your comfort zone? Why does the idea of rapid lethal innovation make you so uncomfortable that you have to write a dissertation on why it's impossible? One additional info, India just notified a 168-kilometer NOTAM in February. Guess which missile DRDO is actually launching? Write your answer in the comments. You ask how we did it so fast. You ask how a nation, supposedly bogged down by red tape and files, managed to crack the code of a next generation propellant in a mere 6 months. You are looking at the calendar, counting the days from the crash of the pl15 to the launch of the Astra, and shouting impossible because you are viewing time as a linear progression of ignorance. You are assuming that on the day the Chinese missile fell into the dirt, Indian scientists were starting from zero, staring at a blank whiteboard with empty minds. How naive, how incredibly wonderfully naive. You have forgotten the first rule of intelligence. Nothing happens in a vacuum. The timeline didn't begin in 2026 with a Chinese mistake. The timeline began on February 27, 2019 in the chaotic smoke-filled skies over Rajouri, when our foolish childish neighbors decided to play with fire and inadvertently handed us the keys to the kingdom. Do you remember? Do you recall the AIM-120C5 AMRAAMs that rained down that day? The media showed you the fragments of the missile casing to prove the F-16 involvement, to score a diplomatic point. You saw a piece of twisted metal with a serial number. You saw a gotcha moment for the news cycle. But what do you think happened to those pieces after the cameras turned off? Do you think we threw them in the trash? Do you think we put them in a glass case in an Air Force museum to gather dust? Let me paint you a picture of the mother lode. While the diplomats were arguing at the UN and the news anchors were screaming about F-16s, a quiet, unmarked convoy of trucks was moving that debris to a very specific, very secure facility in Hyderabad. We didn't just recover casing fragments, we recovered unburned propellant residue, we recovered the nozzle throat, we recovered the fin actuation systems, we recovered the heart of the American military-industrial complex, delivered to us via airmail by a Pakistani Air Force that was too eager to press the trigger. For the last 7 years, from 2019 to 2026, DRDO has not been sleeping. They have been dissecting the MRAM, they have been obsessively analyzing the specific chemical signature of the American propellant grain. The Americans are the masters of minimum smoke, high energy solid fuels. They have additives that suppress the smoke trail while maintaining a burn rate that defies standard chemistry. We spent years reverse engineering that specific American blend. We knew the oxidizer ratio, we knew the binder polymer, we had cracked 90% of the formula by 2024. We had the American base, but there was a problem. We couldn't stabilize it at the higher densities required for the Astra's smaller airframe. We needed a catalyst, a bridge to marry the high energy American chemistry with the thermal limitations of our own indigenous hardware. We were stuck at the 99th yard line, holding a fuel that was potent but too volatile to mass produce. We were waiting for a miracle. We were waiting for the missing link. And then, God bless them, the Chinese and their Pakistani proxies did it again. Enter the pl15 in 2026. Now you have to understand the lineage of technology. The Chinese pl15 didn't fall out of the sky from an alien spaceship. It is in many ways a bastard child of espionage. It is an open secret in the defense world that China borrowed heavily from the MRAM program to develop their own PL series missiles. They took the American based concepts and, being Chinese, they added their own twist. Specifically the CL20 high energy compound to give it that extra kick, that monster range they brag about. So when that pl15 launch darted into our territory, it wasn't a completely alien artifact. It was a cousin. It was the evolutionary step we had been missing. When our scientists cracked open that Chinese motor, they didn't see a foreign language. They saw a variation of the same puzzle they had been staring at since 2019. They saw the American base that they already understood perfectly, but with one critical addition: the Chinese stabilizer matrix for the CL20. It was the eureka moment to end all eureka moments. The Chinese had solved the volatility problem that had stalled our MRAM reverse engineering project. They had effectively written the last page of the book we had been writing for 7 years. This is why the 6 months timeline is not only possible, it is inevitable. We didn't spend 6 months inventing a fuel. We spent 6 months finishing it. The test rigs were already built. The chemical precursors were already in the vats, waiting for the final ingredient. The computer models were already running, calibrated on the 2019 MRAM data. The moment the chemical analysis of the pl15 stabilizer came in, it was just a matter of plugging the variable into an existing equation. It fit like a key into a lock. It fit like clockwork. Boom. The new fuel wasn't a discovery, it was a completion. We took the American foundation gifted by Pakistan in 2019, combined it with the Chinese breakthrough gifted by Pakistan in 2026, and synthesized it with Indian ingenuity to create something deadlier than both. It is the ultimate irony of the subcontinent. Pakistan, in its desperate bid to outgun us, has twice acted as the unwitting courier of advanced technology, ferrying the secrets of the superpowers directly into the labs of DRDO. They fired American tech at us and we learned. They fired Chinese tech at us and we perfected. So to the critics asking how, I ask you, where have you been? Do you think the DRDO is a collection of high school students doing chemistry experiments in a garage? This is an organization that builds ICBMs. This is an organization that tracks satellites. Do you really believe that when they held the pieces of the MRAM in their hands in 2019, they didn't squeeze every ounce of data out of it? The Angdiplex fuel described in the video is not a sudden magic trick. It is the culmination of a 7-year shadow project that started the moment Wing Commander Abhinandan crossed back over the border. The pl15 was just the catalyst that turned a research project into a weapon. We were already working on the mother load. We were just waiting for the fuse. And when it arrived, we didn't hesitate. We didn't ask for permission. We didn't wait for a peer review. We poured the mix, we sealed the casing, and we lit the candle. The result is not fiction in the sense of fantasy. It is fiction in the sense of a prophecy waiting to be fulfilled. The pieces are all there. The history is there. The capability is there. All that is missing is the spark. And knowing our neighbors, it is only a matter of time before they provide that too. So keep your doubts, keep your "it takes 10 years" defeatism. The rest of us know the truth. In the world of defense, you don't start from scratch. You stand on the shoulders of the giants who were stupid enough to shoot at you. Before you cast stones at me again, let me reiterate. This is a work of pure defense fiction. It is not based on reality. We are on the same team and I appreciate you all. My sentiment here mirrors that of Kaushal and Kaushalendra, the hosts of the Monks and Warriors podcast. It is that same feeling they express to the heroes of Operation Sindor. The bittersweet realization that we wish we could have been there with you, but we retired before the fight began.